Hello and welcome to our lesson for today. Please make sure you have a place to take your own notes, and when you are done with the video I will be checking those notes to give you the homework assignment. Today you'll notice we are starting with 4.2, patterns in linear functions, and our objective here for today is that the mathematicians, you all in my classroom, can identify and represent patterns that describe those linear functions. So to get us started here, we have a couple of vocabulary words, and remember vocab should be in your notes. The dependent variable changes in response to the other variable. So this value depends on the other variable, so dependent variable. The independent variable does not change in response to the other variable. It is independent, it is its own value, and any value can actually be used in the independent variable section, and then the dependent depends on what you put in. Speaking of which, the inputs and the outputs are coming here next. Inputs are values of the independent variable. Inputs are something that we can plug into the equation, and we can choose a number to use for that. It is independent, you can choose anything, and the output is the value of the dependent variable after we have plugged in something for the input or the independent variable. So independent variable and inputs are connected, are related here, and output and dependent variable are related here. So as we get started here, one piece of information that is very important as we continue is that the value of one variable may be uniquely determined by the value of another. So the value of one may be uniquely determined by the other. So we have to figure out the answer to the equation when we plug in our independent variable to figure out the dependent. Such relationships may be presented using tables, words, equations, sets of ordered pairs, and graphs, and we are going to see all of those here today in our lesson. So first, for problem number 1, we have representing a geometric relationship. So we've got some rectangles here. The first rectangle, or our rectangle, is 1 by 6, and then we are looking at duplicating that or having multiple side by side. And the question is, what's the relationship between the number of rectangles and the perimeter of the figure they form? Represent this using a table, words, equation, and a graph. So I'm going to give myself some more space here and go ahead and take a look at this. So first, as I look at this, I want to be able to represent this with a table. So I am going to look at the number of rectangles, and that is going to be my x value. So x is my number of rectangles, and I'm going to abbreviate there, number of rectangles, and then my perimeter is going to be found here. And then here is my ordered pair. Okay, so I've got my number of rectangles, how I can find the perimeter based on the number of rectangles, and then I can write that relationship as an ordered pair. So if I'm looking at x is the number of rectangles and y is the perimeter, I know that I am looking at 1, 2, 3, and 4 rectangles, but how can I use that to find the perimeter? Well, I know that to find the perimeter, add up all the sides. So I have 2 of these sides labeled 1 plus 2 of these sides labeled with the 6 to find the perimeter of just one rectangle, and that is a total of, I'm running out of space here, I apologize, 6 and 6 is 12, 1 and 1 is 2, and that total is 14. So my values are 1 and 14. As I continue on here, when I have 2 rectangles, now as I look at the equation or the math that I was doing for the perimeter, I notice that I can actually just switch out this first one for 2 of these sides up there and 2 of the 6th length sides to give me a total of 16. So now my ordered pair is 216. I have 2 3s and 2 6s, and again, this is all, you can see all of this up in the picture up there, or just by thinking of how you find perimeter. And then we have 2 of the 4 lengths plus 2 of the 6 lengths gives me a total of 20. So as I look at this, again, I have 2 of my sides that are labeled 1. That's where that's coming from. 2 of my sides labeled 2, 2 of my sides with a 3, and 2 of my sides with a 4. And the 6 does not change. The 6 is the same no matter what. So this is me showing that relationship in a table. So at this point, I should be able to say that my equation, in order for me to find the perimeter, which is y, I am taking 2 times my x value. You'll notice that the x value is the same being plugged in there, plus 2 times that 6. That is never changing because that measurement of my rectangle is the same throughout. So I've got y equals 2x plus 2 times 6, or y equals 2x plus 12. Okay, as I go to graph this, looking at my graph here, here's my 0. My x-axis is my x values here, and that was the number of rectangles. I'm running out of space, I apologize. And then on this side over here, I have, my y value, which was my perimeter. So I had 1, 2, 3, and 4 rectangles, and I could continue on depending on how many rectangles I would continue to work with here. On the left side, I'm going to count by 2s, 2, 4, 6, 8, 10. I'm going to skip lines here just because I cannot write that small. 14, 16, 18, 20, 22, 24, 26, 28, and the top would be 30. And I can graph that. 1 had a perimeter of 14. 2 rectangles had a perimeter of 16. 3 had a measurement of 18, and 4 had a perimeter of 20. So there, I can plot those there, and now I have this geometric relationship represented with the original diagram showing the 1 by 6 rectangles and then multiple side by side. I have the table there showing that for each number of rectangles I can plug the x value in there into the first spot, the 2 times 1, the 2 times 2, the 2 times 3, and the 2 times 4. And that the 6 is never changing, so I have that represented in the table. And then I also have an equation, y equals 2x plus 2 times 6, or y equals 2x plus 12. Those are the same thing, since that 2 times 6 will never change. Okay, so go ahead and take a moment and see if you can try this as well for this question, the got it question. This one we are looking at triangles, but it is still looking at the perimeter of the triangle, so it will be similar to the previous one. When you are ready, you can resume the video and check your answer. If you did not get the same answer when you check, you should raise your hand and ask some questions. All right, welcome back. So once again, I am going to put the answer up here. If you do not get the same thing or do not understand where this came from, you should definitely be asking a question here. When we are looking at this, the number of triangles and the perimeter are directly related. If we have one triangle, we are adding all of the sides, 4 plus 3 plus 3, and that gives us 10. When we have 2 triangles, we're doing 4 plus 3 plus 3 plus another 4, and you'll notice if I am going to switch back to our visual here for just a moment. You'll notice that right here, when you add another triangle, it is showing that we are not looking at the perimeter of 2 of the triangles altogether, so I'm not counting this line in here because it is no longer on the outside. So the way that they are combining them is important to notice. So we have 2 triangles, the perimeter was 14. 3 triangles was 18, and 4 was 22. And that relationship can be shown by multiplying the number of triangles by 4 and adding 6. And so that relationship is y equals 4x plus 6. And the graph is also shown. So once again, if you do not understand where that came from, please make sure you pause and ask a question. All right, let's continue on here. We do have some more vocabulary words to look at. The first is the word function. A function is a relationship that pairs each input value with exactly one output, and that is extremely important. Each input has one output value. And a linear function is a function whose graph is a non-vertical line or part of a non-vertical line. So basically, linear function, linear means that it is a straight line. So when we are looking at representing that linear function here, the table shows the relationship between the number of photos, x, you take, and the amount of memory, or y, in megabytes left on your camera's memory chip. Is the relationship a linear function? So I am trying to identify, is this linear? Describe using words, an equation, and a graph. So as I look at this here, I know that the amount of memory left given the number of pictures taken is shown in the table. I need to take a look at some other representations of this so that I can determine if it is linear or not. And so I'm going to start off by looking for a pattern. So as I look at this table, I see that the number of photos is increasing by 1 each time. So I'm going to look for a pattern over here. 512 to 509 is taking away 3, 509 to 506 is minus 3, and 506 to 503 is taking 3 away. So at this point I do have a a constant rate of change here, so that is making me lean towards this being linear, being a straight line. So as I see that constant rate of change, I do notice also that I am starting here at 512, and so if I relate this back to my slope and my slope-intercept form equation knowledge, which I did also do in number 1 just a little bit, but as I look at this, I do notice that I am going down, or negative 3, and I'm starting at the 512. So that negative 3 is my slope and the 512 is my y-intercept, or my starting point there. So that's my equation. So I have a table, I have looked at the rate of change in the table, and so I also have my equation there. So let's go to the next slide here, and I also have the graph here. So when I look at this graph, I had the equation y equals negative 3x plus 512. So when I look at the equation, the graph, and the table, does this look like a linear relationship? So as I look at this, what do you think? Does it look like a linear relationship? The answer would be yes, it is a linear relationship because it is forming a line. I can see that because of the constant rate of change in the table. I can see that if I would connect the dots in the graph, it would form a straight line. And I also can see in the equation that I have a constant rate of change as well with the negative 3. So go ahead and take a look at number 2 here, or the got it for number 2, I apologize. See what you think. Does this form a linear relationship? Don't forget to look at the table as well as making or thinking of a graph and equation. All right, welcome back. Hopefully you feel pretty comfortable with this, but as you look at this got it question here, this is a linear equation. You can notice that the rate is increasing by 1 on the top, and on the bottom is increasing by 2. So your equation is y equals 2x plus 8, and your table would form a straight line going upwards starting at the number 8. All right, so one last thing here real quick. Does this set of order pairs 0, 2, 1, 4, 3, 5, and 1, 8 represent a linear function? So as I look at this, one thing that I want to think about is what would it look like if I graphed this? And on a quick graph here, it is not going to be perfect, but 0, 2 would be about here, 1, 4, 3, 5, and then 1 and 8. Does that look like it would form a straight line? And the answer is no. So this is not linear, but also one other way that I know it's not a function right from the very beginning is each input can only have one output. So if my x value is repeated and it has a different y value, then it is not a function. So when I have 1, 8 and 1, 4, the input of 1 came with two different outputs, 4 and 8, and so therefore it is not even a function. So if I remembered that, I wouldn't even have to think about the actual graph itself. All right, so at this time, you should have some notes written down. Once again, if that slope and that slope equation is not familiar to you, that is something that you do need to be practicing and be thinking about and asking questions about, definitely. And so at this time, you can show your notes to me to get your homework assignment.